Hello, Jennifer. It's Bob. Took a look at the project. I think the issue that we had here was input in millimeters and then, converting and drawing things. I'm going to work on that, but I think that was it. So what I did is I took your project, I input the X and Y coordinates along the wall, drew it up, came out with the estimate. Everything looks like it's working pretty good. So just let me run through, show you what I'm doing here. Make sure we're on the same page. So what I did is file open, and I named it with RR, so it's my modified file. So we're going to load it. You're going to see the bar advance across the bottom, meaning they're loading all the sections, or we're loading the drawing. So that's coming in. And there we go. So that's the elevation that I drew. Let's go back to the project. So it's Falcon Lane. I put my initials in here, RJR. If I go down to the wall layout, that's where we input. This was the data points that I got out of your file. X coordinates 0, 20, 40, 56, 80, 90 meters going along the face of the wall. Top of the wall 425.8, bottom wall 425.5. I just duplicated. I didn't put any top slopes, live load, none of this is in there. And with this, we'll go draw the wall. This is just a check to make sure that we've looked at the surcharge loads above the wall, slopes above and below the wall, seismic settings. You can check these off and proceed, or you can do like I do, skip it because I know I put them in there. These checks right here are saying that at these stations, check data at 40 meters, because the distance between the last point and this point is more than 10 feet, it's more than 3 meters. So I do that just in case you've put a data point in that's way out of whack. Generally your points aren't going to be that far apart, but this just gives you warning. If everything looks good, we say continue. Thing's going to kick in. It's going to calculate all the point. You can see the progress bar as we're zipping along that wall. And there we go. So this is a new elevation. We can zoom in on it. A lot of noise here because we're showing a lot of stuff, but I label every, let's just get rid of some stuff here. So I label every step in the wall. So we've got a top of wall, bottom of wall. So when the contractor goes to lay it out, we can see that, hey, these are what the elevations it should be, and you can see where we're stepping up here. In a final design, what I'll do is I'll come in, I'll select, and I'm probably going to delete maybe every other one, or maybe more than that, just to clean the view up, just to get something that looks a little better. And, come back here at the beginning. Yeah, I need where the wall begins, but then as we step up through the wall, I can trim those out. So that's going to look a little better. Also, when we get into looking at the wall, we can see, well, our grids don't line up going across here. This is something else that I always clean up. So if I come in here at, this looks like about 13 meters. Let me put that up there. Let me put this down here. I'll go to geometry. I'll go to 13 meters. There's my wall elevation, and at 13 meters, if I move my grids down, and I'll click on the down button, I'll update the view. Now you can see that the grids line up across. And I'll go over here to 20. We just use the tab button here. I can move those down. I'll update that view. That one looks good. Coming across here to 24, same thing. Probably move those up. And you may not want a grid right at the top block. So if you want, you can do a shift arrow down, correct that one, update the view. That looks good. Now the other interesting thing here too is we can go station by station here, but maybe you want to say, okay, I'm 2.5 meters. Let me run that across. So you can hit the right button here. That's going to copy it to the next section. So all the elevations are the same. All the lengths are the same. And maybe you want to go even more. But look down here. We've got a red block up here, which means the top of the wall is not stable. So we can click over here. We can insert, pop another grid in there. This probably doesn't need to be so long anymore since you're not going beyond the failure plane. So we can shorten those up, whatever you want, update that, and now boom, we've got the same length, we've got the same elevations, and now we've got a really neat section in here. A lot easier to build. You want to keep the grids on the same elevation if you can. Don't keep changing lengths a lot. That's harder for the contractor to keep up with. But say we've gone the whole length of the wall, we've got it like we want it. Okay, now we zoom down a little bit. Let's get that thing fit in there. Yeah, something like that. Not too bad. Now we can take and look at our quantities. So we've got 241 cap units. We've got 1.5 block, and we've got 1791 on our wall blocks. There's the area, 177.6 square meters. And if we add a contingency, there's the numbers there. We've got 547.2 square meters of geogrid. There's our contingency. There's a number coming out. We can look at this two ways. This is counting the labels on the units, which we got turned off out here. But if we actually just want to count the blocks in the wall, this is cap units, half blocks, wall blocks. It's just to check that we draw the right number of blocks. It corrects for the right, checks for the right number of labels. So either way you want to look at it, it's good. Not much difference here with segmental retaining walls, SRWs. We don't usually label those blocks. That gets very messy, but with big blocks, the PMBs, we do need to label them because we've got bottom blocks, middle blocks, top blocks. Anyway, so that's moving along there. Now if we go to where the issue was printing the estimate, I want to print with the elevation view. I'm just going to leave it defaulting to 8.5 by 11 paper. We print those up, page 2, 3, 5. There we go. There's our sheet. Now if we had a plan view, that would have showed up on here, but we don't. There's the elevation view. There's your soil parameters. Your input, there's your leveling pad data. There's our block count. So we got 241 cap blocks, 1/2 block, 1,791 wall blocks. And there's your geogrid 547. So there's our quantity takeoff right there. Fill table behind the wall, a little overview on what I'm doing, and there's our input data there. So at this point we could print it out to a PDF, we could print it out to the printer. It's out the door. So let's close this. We're done with the project. We could say save design, and this is where I saved it, up here. We replace it, yes. File saved, and we're done. So pretty quick overview, but everything seems to be working pretty good here. The rest of this week I'm going to work on the millimeter to get that working. What we do here in the Imperial units, we input the data always in feet, and then when we go to the AutoCAD drawing, we have the option of drawing in inches or drawing in feet. And just the default in AutoCAD is the default units are in inches. And then when we print out in architectural or engineering units, it converts it to feet plus inches. Pretty simple. When we go in the metric side, this is really confusing because if I go to Australia, they do everything in millimeters. If I go to Japan, they do everything in centimeters. Canada, you're kind of all over. Some people will draw in millimeters. Some people will draw in meters. What I'm doing here in the software is I'm drawing everything in meters. So, and where our problem is when I draw in millimeters, I've got to scale everything up. So I'm going to work on that. I'm going to get it fixed, and I will send you a new update next week. Any problems? Any questions? Give me a call. Shoot me an email. Thanks.